but we're really glad that you're here and that you've chosen to be here. You know, the opening session had a few quotes which I thought were quite appropriate to what we're going to be talking about very soon. One of the big questions for the forum itself is what matters? And how do you make choices which matter? How do you make actions which matter? And what is growth? How do you grow? And how can we help folks grow everywhere? And the final quote I loved, which is only dead fish swim with the current all the time. I think we have three individuals who are sitting here in our panel who one would say do not swim with the current all the time. All three are very alive, very vital, and truly trying to make change happen all the time. My name is Chris Lubkeman, and I have the pleasure and the privilege of leading the Strategic Foresight Hub here within the Office of the President at ETH Zurich. And I will be your host this afternoon for the Rethinking Science for Innovation Markets session. The title compels us to acknowledge that the traditional pathways from scientific discovery to market application are no longer sufficient in the landscape of our rapidly evolving world. And sometimes that evolution is starting to become unrecognizable. We must all become more prepared to answer the question, how can I, or how can we, better translate groundbreaking research into tangible innovations that address our collective global challenges? We must also consider how to make these scientific endeavors more inclusive, more responsive to the dynamic needs of both growing and existing innovation-driven economies. I'm truly pleased to we have an incredible panel who will share their understanding and interpretation of just what agile and impactful research can do in our world. Our time together will be 60 minutes. We will conclude at 16:15, as if we're the SBB. I'll try it on time. I'll make sure we end, even if our conversation is hot and interesting. And first, I'm going to ask Liz, Soli, and Nanli to tell us more about themselves, and then about their work and the impact which they're having and hoping to have. After our conversation up here, I will move to engage your questions, which you can submit on Slido. And so you can submit these questions at any time, and they'll all appear right here like magic. And I'm sure for my grandparents, this would have been magic. And I will get to every one of them that I can. I can't promise we'll get to all of them in the panel, but we'll get to as many as we can. And those of you online will also be able to ask those questions through Slido. And we thank you for your presence with us, even if you're not here physically. I'll be monitoring those throughout the conversations to try to integrate them into, and I'm getting a sign that the Slido is not working. There's no internet. Well, you do know what the T stands for in ETH, right? I was told that the internet kind of goes up and down in this room periodically, so maybe we have to do the old-fashioned thing of you write them down on something for a moment, and then when Slido comes back up.
They can join the public Wi-Fi network. That works.
Okay, so you can join the public Wi-Fi network. And we ask you to do that as part of the public here in our room today. The ATAL intern one doesn't seem to be working for us. But please do that. So, are we ready? Anybody ready in the room for this? We'll get started? Thank you. Thanks, Liz. I appreciate that. At least one is. All right. So, Elizabeth Tilley. Hi. What do people in the room need to know about you in the context of the conversation we're going to have?
There's a few things. So the first is that currently I'm a professor here at ETH in the Department of Mechanical and Process Engineering. But I would call myself a sanitary engineer. I would call myself someone who works towards SDG 6, someone who's maybe had a background related to toilets and NGOs and development much more than a typical mechanical engineering professor might. My first job when I was 23 was working in Mexico, building toilets for a small NGO, and just kept the love of toilets going on and on and on. Did my PhD, I was mentioning, in South Africa, looking at urine diverting toilets. And before I came to ETH, I was a professor at the University of Malawi in Malawi for 5 years, and was lucky enough to leave that job, although it was a wonderful job. 5 years was enough, and now I've been here for 4 years.
Great. Well, welcome. Thank
Thanks
you
so
very
much.
much. It's fantastic. And Soli Makaliso. I know I didn't say
Yes,
your
yeah.
name right.
It's a difficult one to pronounce. Normally it's Soli Makotliso, but here we say Makoliso.
Yeah, sorry
So
about
that
that.
goes, yeah. I'm the Deputy Director of the Essential Tech Center at EPFL, or ETH Lausanne, since we're in Zurich. My background is I'm a biomedical engineer by training, and I spent over 15 years in the world of entrepreneurship. I was working with startups. I started in the US, where I started my studies, and I concluded my studies here at EPFL, in my doctoral studies there, after which I continued to work in the field at the Innovation Park there in the area of entrepreneurship in the life science sector. But being from South Africa originally, I always had this urge and wish to try and connect and tap into all the resources and all the expertise that I was seeing around myself on campus, to try and see how we could, leverage this to at least start to address some of the challenges that we see on the continent. And this finally gave rise to an opportunity for me to go back to EPFL to join hands with my colleague, Dr. Klaus Schönenberger, who had actually started the Essential Tech Center there. And I joined hands as the vice director and developed the center to at least some of the projects. One of the projects I'll actually be telling you shortly.
Great. Thanks, Soli. And last but not least, Natalie Landrau.
Yeah.
Who are you in the context? What does everyone in the room need to know about you?
Wow. I'm Nyanli Landro. I'm from Togo, which before 1960 was considered the Switzerland of Africa. Not sure if it's still the case. I don't think so. But I grew up in Togo, traveling in Africa before, and coming to Europe, where I was hosted by my uncle, and I got the opportunity to study at EPFL for my master degrees, my master thesis, and then do my PhD at ETH Zurich at the chair of sustainable construction. The interest for me was how can we use local resources to build more sustainably. Therefore, the topic of my PhD, development of low CO2 clay-based building material. Founder of Oxara, a ETH spin-off. CEO of the company, have 14 people that we work with. On the side, I'm interested in fashion. My sister does most of the clothes that I wear, and I'm quite proud to show it here today.
Go family. There you go. All right.
and otherwise, music and traveling as a passion. So, yeah.
That's beautiful. Thank you. As you can see, we have a great group of bridge builders. All three of you building bridges between time, place, and cultures. I'm looking forward to hearing more about the project. So, Liz, we have some slides.
Yeah,
I think right there.
excellent. Oopsie daisy.
Tell us about the project.
We lost them.
Boop. There we go.
But I think you introduced it really well when you talked about, you mentioned from the plenary what matters. And for me, what matters is SDG 6, universal water and sanitation. So if you maybe have your own personal favorite SDG, I want to convince you that this is, I think, the most important SDG. It's one of the ones that I think matters the most if we're thinking about mortality, morbidity, and especially child health. On this figure, you can see some of the causes of death, the leading causes of death among children under 5. And you'll see respiratory diseases and diarrhea as 2 of the leading causes. So this is really just a function of fecal matter, of poop, of human waste, getting onto hands, getting into water, getting onto food, and causing ultimately death in children. And this is a very, very preventable disease and very preventable in terms of technology. You know, we've had toilets for a very long time. We've had chlorination for water for a long time. So the question is, why do we still have a child dying every minute from something that is so preventable and so easy to do? And this really drives all the work that I do in my group here in the Global Health Engineering group at ETH. And so one of the things that I wanted to present to you today was something that we came up with. It was actually about a series of 6 different master students. I'm very, very lucky to be in the Department of Mechanical Engineering, where we have just brilliant mechanical engineers who are able to take these challenges that have been traditionally the field of health practitioners or epidemiologists and really start to think about what are the concrete technical innovations. So this doesn't look like much maybe for you right now, but what it is a way of heating up the effluent from a fecal sludge treatment plant and killing all the pathogens. So when we have feces, we put them into a unit where they can be treated. They actually release gas during that treatment process. And so what we do is we harness that gas and we use that same gas to heat up the effluent, kill the pathogens, kill the bugs, kill the microbes, and then make sure that we have something that when it goes out into the environment, it doesn't get onto those little hands and feet of the children who might be at the school where we work or just in the regular environment. So you can see here 2 photos of 2 of our students and our collaborators. In this, we worked with various pit emptiers in Kenya. So the pit emptiers are actually the men and women who would go to your house and empty the feces from your pit latrine or from your septic tank, bring it to our treatment facility, and then it's further processed by our team on site. And you can see Julia and Ludwig, who are both involved in the design and implementation. We're still a couple of iterations away from having this commercializable, but it's something that we're hoping to realize in the next couple years.
That's great. Thanks, Liz. So let me, quick question. How come no one's done this before?
It's an excellent question.
Thank you. Well, they pay me the big bucks, which
I
is like
think-
nothing, but it's okay. Yeah.
There's a few good answers, and I think, you know, looking at the picture on the right is one of them. This is dirty work. You know, when you have the choice to work on underwater robotics or other types of really flashy AI, maybe this isn't the career that most people choose. It involves a lot of coordination, a lot of social skills, a lot of social science. It's really interdisciplinary, and I think getting together the right team, getting together the people who are interested in it, passionate about it, and who are not who don't succumb to those taboos, who recognize that this is one of the most powerful and high impact health interventions there is.
That's great. Yeah, great. Thank you very much. Maestro,
Yes.
how about you? I mean, Soli,
Yeah.
you've got a whole group also, which has been focusing on innovation.
Yeah.
What do we
Yeah.
got?
What we see there, for example, is what we term a hospital equipment graveyard, which is essentially mostly medical equipment that actually is non-functional. And as you can see that statistic there, it turns out that almost 70% of all donated medical equipment never gets commissioned, according to the World Health Organization. And why is that? It's primarily because most of those devices were not actually intended to function in this type of context. They were primarily intended for markets in the high-income countries, and so when those markets are saturated, then they are exported and look and seek other markets. So, in other words, the motto is design it for the West and hope that it will be fine for the rest. So this, to us, instead of looking at this as a graveyard or a place where things come to end, we saw the emergence and the birth of an opportunity to actually rethink how we conceive the innovation of these types of devices. If we look at the next slide, and this actually led us to really, how we did this was to really rethink, come up with a new framework in which we conduct our work, which is predicated on 3 pillars. The first pillar being a cooperation and collaboration with the relevant stakeholders in the affected regions, where we are able to carry out a more accurate needs assessment and definition of the problem, and then the type of solution that we should work with. And then the second part is actually predicated on interdisciplinarity. So what I mean by that is that we don't only confine ourselves on trying to demonstrate technical feasibility of the solution that we want to build, but we also look at issues such as economic feasibility, social acceptability, and environmental suitability. And this is also another key term in this phase is co-development, because we continue to work with some of those stakeholders that we identified in the first phase. And this allows us to de-risk this innovation to a maximum before we then transfer it to the field for deployment at large scale, because our vision is primarily the attainment of sustainable impact at large scale. And so here, one of the mechanisms that we look at is that of entrepreneurship. So we can actually do tech transfer if there is no private partner or private sector partner that is available to uptake it. We can then create our own startups, which we've done in this case, or we can actually do the tech transfer to an existing one. Now, what is important, what we see there is one of the very first flagship projects that we actually carried out. That was a result of a long-standing call from the World Health Organization since 1974, where they were actually asking for a universally accessible X-ray medical imaging system. So to cut a long story short, that was the work that we started in 2012. We had the first prototype in 2015 and the final prototype in 2017, and an enterprise was then created to actually industrialize that machine. It is now, if we fast forward to today, we are looking to actually deploy it primarily in sub-Saharan Africa first, and where we want to, where we've decided to have our main operational hub in Johannesburg. And we have actually, currently we have 2 X-ray centers that are based in the townships, in underserved areas in the townships of Johannesburg, in Alexandra, which you see on your left, and Soweto. And as you can see there, we have a state-of-the-art machine that actually has a turnaround time that is even better than what we have in Switzerland, as I'm told, and whose image quality is even superior or equivalent or superior to some of the market standards that we find here. Now, equally important in the whole process is the actual business model, the question of the business model, because when in bringing this to to these regions, we, instead of actually thinking of selling the machine, as is usually the case, we the company actually decided to implement a business model of actually building X-ray centers in the underserved areas. They would build them themselves, And then clients and the patients would then come and they would be charged a price that is affordable and less than what is the national standard. And so because this allows at least a timely integration or deployment of this type of technology without having to wait for availability of budget and the long sales cycle that are typically related to this type of equipments. So what is important, though, is that when you have an X-ray machine that is very low energy consuming, and that has all those features of suitability, ease of use, robustness, people are naturally interested in it here as well. So because it is CE marked and it was done according to international standards, there is actually a demand for that machine now, even here in Western Europe, and yes, for example, here in France. So we are very pleased to actually see that we have now been able to actually put something on the market that is universally adaptable. That machine is capable of functioning even in the most remote regions of sub-Saharan Africa, but it is also able to provide an equivalent or even superior quality even here in high-income countries.
That's really great, Soli. Thank you for that. Sort of like this, on one hand, leapfrogging and then refrogging. Leapfrog both ways.
Yeah.
I don't know what the right term is, the boomerang.
Exactly.
Yeah, that's fantastic. So, Nanli, what about you? You have also a fascinating project of quite different type, different scale.
Yeah.
Tell us about your project.
So, as I mentioned, Oxara is a ETH spin-off, and the challenge we try to solve is the sustainable construction and affordable housing. So I'm sure that when you all woke up in a house today, but I'm not sure you have realized that your house or your apartment or your building is built mainly with concrete. And in the concrete, you have cement that contribute to 8% of global CO2 emission, right? So that's kind of, if you are trying to address the climate change issue and achieve net zero, we need to drastically reduce the impact of the cement. The second aspect is that the resource that is used to produce the concrete corresponds to about 30% of global resources that are currently used, and those resources are getting scarce, such as sand, gravel, and so on. So what Oxara have done during my PhD here at ETH is that how can we use waste, mineral construction waste that are quite available, and earth from the ground that are quite available everywhere, and turn it into new cement, new product cement that have 70 to 90% CO2 reduction compared to conventional cement, and have structural performance for 3 to 4 story house building, because those are kind of the application that we see in Switzerland. It's 60% of the building is 3 to 4 story house, and in Africa we mainly build 1 to 2 story houses. So not interested in the high-rise structure. So that's what we did during my PhD here at ETH, is to develop what you see here, this white powder, like white magic, not to say black magic, which is a cement-free binder, waste-based, so promoting circularity and the decarbonization. And since 2019 that I finalized my PhD, we have tested the product not only in African countries, but also in Switzerland with different leading Swiss constructors, like a Keybag, if you know, they are based in Zurich, Holcim, for instance, Marti. Those are leading Swiss companies interested in using our product, but also in Rwanda, in Cameroon, and in Ghana. And if you look at the next slide, here is a first prototype that we did with our product to show that it worked. And it works in different areas. You can use it for bricks, you can use it for concrete walls, application for flooring, and for different things. And here we build it demonstrating that you don't need regular cement and regular concrete to do all this structure. 0% cement used in this application. The second one is a project that we did in Dubai, which is an installation of our product. So they have also their waste, and they are trying to reduce the amount of waste. So the transferability of our technology, not only in the Swiss market, but also other markets, which is proven. The third one that I couldn't show is the Swiss Embassy project we are doing currently in Cameroon, where for the construction of it, they were looking for low emission cement, and then they asked us how we can provide that. So for this project, we have done all the tests, and now the product will be shipped the coming weeks, like 2 containers to start the construction. And the long term is how do we set up an infrastructure locally so that you can produce with the local resources directly. So yes,
Fantastic. And if you think of all 3 of them, they're really trying to address a profound need, actually, from all 3 of you. And I found it quite interesting, especially with you. 70 to 90% reduction in CO2 in one of the most common building materials in the world.
Yeah.
And that has a profound impact. Or helping the health of children and grown-ups all over the world. Or how do you take this other technology that we get as a normal and be able to utilize it, and then also the slingshot back and forth. I have a couple of questions, and I see there are 3 or 4 questions have come in on Slido. There it is again. And for those who want, please do submit those. Each of you have talked about collaboration, either directly or indirectly. And this is the theme of the conference here right now. What collaboration was crucial to get the project over that uncanny valley of, oh, it'll never work, or what was the crucial collaboration? Who would like to? Liz, you're like going like this.
Oh,
Yeah, go for it. I like that. Yeah.
No, I think what's interesting and unique about this project and really about the way that we work with all of our projects, we don't spend a lot of time in the lab. We don't model it to death. We don't, make sure we have the perfect design before we go and start testing it in country, because the reality is so unpredictable. So when we're working with human excreta, we're working with poop, you can't predict the properties. We don't know how thick or thin or dry or hard or filled with trash or hair it's going to be. And so the only way to figure that out is to do it, to pilot it, to fail, to iterate, to fail, to iterate and fail. And so the key collaborators that we had with this were the pit emptiers, so the men and women who would bring the fecal material to us, and the wastewater treatment plant who was allowing us to process and experiment on their site. And if we hadn't had that, we would have had to use, very homogeneous, nice Swiss feces or, fake poop, which just wouldn't have been the same.
No, that's great. Soli, you also talk quite a lot about a very similar necessity for rethinking the process.
Exactly. As I mentioned, that code development is one of the pillars that we that actually underpins our work. If I give you a specific example, if you look, for example, at the X-ray project that I showed you there, we had chosen Cameroon as the pilot region, the pilot country to work with. So for each and every project that we do, we typically have 2 project leaders. And in this case, we had one in Cameroon who was a radiologist, and we had an engineer here in Switzerland. So when you have that type of situation, it means that the people in Cameroon have information that we don't have us here as EPFL, and vice versa. So there is an open exchange and a process of learning that goes both ways. And this is very enriching and allows us to really have an honest exchange of what needs to be done. And this is the code development is very important. I'll give you an example. And with this X-ray, we, for example, had one of the consoles where that the radiographers use to try and carry out the exams. When we tried it with those at the University Hospital of the Chouf, they had one configuration that they loved. We took it to Cameroon. It was a total disaster. So I think it's important that code development must be integrated, must be an integral part of the process.
Yeah.
And we actually use that first phase to really nurture this and actually develop the right partnerships that enable this afterwards.
So let me follow up with that before none of these. So there's a question that came in here. What's the role of the Global South, or in the sense of where each of you have been doing your work, their research and innovation institutions in your projects? Have you, I mean, your partners locally, what's their role? What's there with the research and their innovation there, in site, in land?
I mean,
Go for you.
as I was saying, I mean, if you look at
Joburg's got like 3 universities right there.
Yeah, yes. No, but even during development, it's important because the radiologists, for example, they are the ones who really understand how this machine is used, what is the actual use case, how different is it from here. So I think, and part of this, for example, we were working with the University Hospital of Yaoundé, and so we have the professors there who teach this, who actually use and so they were the ones who were giving us the input, were giving us the specifications.
Great. So there was that collaboration. Nani, what about for you? I mean, you did your PhD here.
Yeah.
But what about your colleagues at home or in other countries?
Yeah. First, you mentioned Oxara stand for community. And for us, it was important that any development or process of implementation is grounded in this concept of ecosystem, co-development and co-sharing, right? So although the main part of the development was done here, the implementation, we had to collaborate with the local industry partners. And in Oxara case specifically, we didn't have to collaborate with local universities and so on, but in the implementation right now for the Swiss embassy, we work with a local brick manufacturer and local concrete producer, right? So we had to find.
But most systems don't like change, and you're talking about change. Each one of us are talking about changing a system, in a way disrupting a system. You get resistance, local resistance. How are you doing this? How are we smoothing this? Liz, you go ahead. Liz, you go now. Then I'll let you. Then you guys. So how do you?
I think ours is a little bit of a special case in that I think there is a really strong demand for it. There's been a massive boom in decentralized wastewater technology. You can go to any city in Africa and buy a biogas reactor. What you can't buy is a post-treatment. And so I think for the NGOs, for the big donors, for governments who are interested in rolling out this technology, they're looking for that missing piece. So I think it will be disruptive in terms of what is produced and what is available on the market, but I think it's certainly demand-driven, and it's something that people are looking for.
Okay. None you were going to answer then. Go ahead.
Yeah, no. Like I was thinking on it from from an academic and a business perspective. And what ETH4D now have set up is this ETH and African University collaboration to kind of bring in this, or bring the two institutions together, or a different university and ETH together to kind of do the knowledge transfer, because key technical problems that are asked here are maybe different to what need to be addressed on the Global South. So we need to address it from their perspective and through the lenses and the question specifically. Now, on the implementation, where the business is as a topic, for me, it's always, as Oxara, initially we wanted to have a kind of non-profit business, but we realized that actually the informal sector is 80% of the GDP of a country. So this informal sector also have certain economic power, right? Yeah. So they are able to buy stuff, and they have what is called the informal structure. So there is still a structure in this informal area. So how do we bridge that with the Western technical knowledge? It's for me a point that I see quite fascinating in this process of knowledge transfer and to bring technology there. Yeah.
So how do we, so the questions came in, which is I think all three of you are trying to address, is how do we bridge and rethink this flow between, say, ETH, EPFL, and other countries and back? And how do we rethink this, especially how do we scale solutions? The direct question is, what can be done to help bridge the gap between research and scale? What's working and what could be done better? What is working? I mean, obviously, I think all three of you are exemplars of what's working, but what could be better? How could it amplify? Because we need to reduce our carbon. We need to reduce deaths. We need to get this your technology. How can it happen better, faster? And I'm not really a silicon head either. So.
Well, it's actually probably part of the answer I would give is probably linked to the question you asked before. Because it is indeed a big challenge of you may have your invention that seems to work very well, but the chances of it getting adopted may still be a challenge even when it's there. So
but what are you doing? I mean, what are you doing exactly?
So in our case, one of the things that we did in recognition of this challenge is, for example, when we start a project, while we are doing the research, I'll give you an example of what we did for the oxygen concentrator, where there was a high, child death mortality, especially in the rural areas, because of lack of, oxygen, etc. So while we were trying to look at why these concentrators fail in those regions and how to make them better, we also had a work package that was running alongside where we fitted, for example, 25, that was part of the grant application. We fitted about 25 district hospitals in the Bungoma County in the case of Kenya. And the goal there was to really start to introduce the use of, on a regular basis, of an oxygen concentrator, even though it wasn't perfect. And also make sure that people are trained, are comfortable, and are happy with integrating it into their workflow, so that when you come with a new innovation that has all the improvements, it can readily and seamlessly integrate there. So I think, because this is one of the challenges that I think needs to be looked at.
So I think that's a really, really, really important point, how it integrates into an existing cultural workflow, into an existing cultural context, right? I think, Nana, you were writing a whole lot of notes.
Yeah, but first I will start with a story. So, and my grandparents were telling me how we start adopting medicine in the north of Togo. So initially, when we were getting water that were not treated and we were drinking it, the local were we were sick, and then a Western doctor came to Europe. We're trying to teach the local how to purify, which mean boil it, add this and so on. But they were not agreeing with him. And one of the someone who was local understood the Western guy. What he was saying is okay, you know what? In this water there are bad spirits. If you boil it, all the spirits go away. So that's what the local understood and got as a concept to improve their health, not by telling them all the technical things, features of the product, right? Yeah. That said, what we need to do specifically, it's for me, it's and I take it from the plenary session before, is how do we transfer this knowledge that we have to the locals so that it's become an appropriation of them to do it by themselves. Yeah. Because as long as we are the one to say, here is the final product, you can use it, and they do not see the value by doing it themselves, it's quite tricky. So the IP transfer, it's one. And then job creation, because as soon as you start creating the job there, and they are part of the value chain, they are part of the economy, then they start integrating it also in the livelihood.
So this is what you're doing?
Yeah, Exactly.
Yeah, and I
And
see you're
that's what
shaking your
we are
head,
doing
and
with
all of you are shaking your head to this one. Yeah. So it's the IP transfer. So you go and you say, here, I've got a really cool product.
Yeah, like it's not that simple because also with
Exactly.
ETH we have boundary like in terms of regulation, in terms of IP regulation and so on. So you cannot just go there and share the IP, but you need to kind of find a good local partner who is willing.
So how did you find your local partner?
Me, I was lucky. I know quite much the people in the region where we are working, and some were actually also from ETH that have studied at ETH and went back. So the African association that we had here put us back in contact and then supported us in this.
So it's a network. So how you can connect, and this is what I'm very often with the international community and the international organizations can help with that connectivity. I mean, this is something.
Yes.
So, Liz, you look like you wanted to say something, and I stopped you a few minutes ago. Do you remember what it was, or?
I
or
think
do
maybe just in terms of the rollout and what's working and what's not working. I think, I consider myself a public health practitioner. I think that in the field of public health, we can't or should not make a profit off of health interventions. So one of the things that we're really interested in with this technology is making it available for replication. So if there's someone who's interested in the design and the hardware and the software, we're very interested in sharing that. And we know that, anyone with a 3D printer and some welding skills can do so much now, right? It's not that we need to sell pre-made technology to have it disseminated. So it's just something that we're very interested in, is understanding the spread and the natural adoption of things that are made open source.
So, thank you, Liz. I want to come back to the title of this moment here, which is the Rethinking Science. Right? Rethinking Science. What does that say to you? Right? When you think about this, especially in this back and forth, north, south, east, west, what does that say to you? And how can we? Is there something that you haven't done? But you said if you had a magic wand, what really could do? There's this group and here. We have a lot of people who can make things happen. What would your magic wand wish be? And this, go, Liz. You're like
No, I'm just to rethink science.
Rethinking science, or what they could be doing to help with the innovation flows, back and forth, learning.
For me, and it's a question of how do you make these complex issues or complex products simple and adaptable for the respective region that we are talking about. Would be the best way to rethink for me science. An example, like, yes, climate change is a huge topic. Circularity is a huge topic. But here in the West, when I go to Cameroon, people use waste but don't talk about circularity. So all the science behind circularity for them, it's not
Not
like
relevant at that moment. Yeah, it's not
like,
part of the language.
But here it's part of the language, part of the education, part of the science, right? So there it's like a completely new thinking to address and understanding that is really a key aspect. The second is the complexity of the science here to there need also to be addressed. And rethinking science, for me, that's what I take out of it, is how do our deep tech innovation here translate locally there, but explain through the lens of the science knowledge there so that they are able to implement and adopt it.
So contextualized storytelling in a way.
Yeah, contextualized storytelling, but also the infrastructure, because they do not have similar infrastructure, and science also come from from the mechanical electrical engineering process,
Yeah.
and the tools necessary are completely different.
Quite
So
different.
you need to
Yeah.
readapt, reimagine everything.
Thanks. Any thoughts from the two of you before I go to another question from Slido?
Yeah. I mean, we all acknowledge how powerful science is and the accomplishments it has brought to society. But at the same time, it is said that we still find the huge majority of humankind in the state that they should be. And science clearly has a role to play there. But of course, that all depends on those who actually drive the trends of science. And so we need to probably rethink this whole, this whole ecosystem in that context.
Hear you. I'm going to pop through some questions here. Short answers. See if you can. This is a short answer question, or maybe not. Which one is more important for impact? Genius, innovation, or a creative business model deployment strategy? Short answer.
Business model.
Business model?
I think it's all of the above.
You can't say both. Come on. Genius or business model strategy? Okay. Pass. All right.
I'm not
I'm
sure
torn.
genius is necessary.
I think,
Genius isn't necessary.
No.
Persistence is more important. I would
Persistence
say.
is more important.
Yeah.
Okay, whoever answered that, you asked that, you heard it here. Interesting. Here, a couple more. How do you think we can involve children and young people to co-create innovation from their perspectives? And do any of you, give play a role in your work? We've stumped the panel on this one.
Sorry, I'm not sure.
What's the role of children and play in innovation or in your work?
Personally, I grew up building houses. That's how I got into the topic of building because of clay, building with clay, and so on. So I think it was initially part of a game to help my uncle to build, and then it got impregnated in what I'm doing. So, and here I see quite a lot of kids also playing with clay material, but it needs to be safe for them. So, yeah.
Okay. I think the rest of you are kind of going, I'm not going to answer that one. It's okay. Okay, cool. Yeah, we don't want people playing with their poop. That's not a very good idea. I'm with you on that one. Here's a question which I'm hesitating to ask, but I'm still going to ask it because it was submitted, and if people give a thumbs up. Do you think, but potentially, my word, higher government corruption in Africa hinders the startup community? What are some possibilities for the future in terms of addressing this challenge and fostering a more supportive environment for entrepreneurship? All three of you are working in Africa, different nations. What do you see as some necessary actions in this domain? None of you are politicians, but all of you are.
Yeah. I think, I mean, we cannot, deny the issue of corruption, which is a legacy of other things we won't go into.
Sure, 100%.
But that said, it is vitally important to engage with the locals, because they will tell you ahead of time what will or will not work. And so for us, this is one of the approaches that we've adopted to at least.
What comes back to the co-creation, co-development, co-presence,
Exactly.
which you mentioned before.
Like we see now, and that's what I was saying, like startups, really great fancy word, but locally, like there's micro businesses that you can consider as a startup, but they are not called startup, right?
Yeah.
So that's kind of, for me, what we are discussing is like, yes, circularity, those great words for the West. What does it mean there, and how is it associated?
Interesting.
And
That's a great point.
As I mentioned,
Really great point.
80% of local businesses, not formal, informal business, are what we call here startup, because there's the mother who is selling something on the road to kind of supporting this and this one. 80% of the the GDP in Africa is run by this local economy. So it's important to consider them as also a startup. Then there is the formal startup ecosystem, that is where you go and raise enough money and so on. Yeah, we see that now it's emerging, it's growing, but not as fast as we have in Europe, but more and more of ETH students that I know were here go back to set up their own business there. Yeah. So with possibility to access of funding through the Europe.
So the opportunities there. Here's a really interesting question, and I think it's to all of you. How can we capture innovation from the Global South and foster support the innovators? Why is it still that the South is providing the context, the poop, and the North the technology? How can this framework change in the foreseeable future? Great question. Answer.
You want me to answer that one?
No,
Yeah. I mean, I would say it's an excellent question, and certainly, I mean, you could find 10 times the number of people from Malawi, for example, who are working on similar technologies. I'm here today because I'm a professor here, and this is what I've always done, and am trying to contribute with my skills and time. But I think the innovation has taken off, and if I can just touch on the previous question, you know, what I see is the limitations for entrepreneurs, for startups. It's not the ideas, it's not the ingenuity, it's not the education, it's internet, it's electricity, it's fuel for transport, it's products, being able to import, you know, machinery and equipment, it's the tariff structure. You know, there's so many more barriers that entrepreneurs in the South face that we don't. And so we're in a very privileged position that we can work on these topics, but certainly we're a small drop in the proverbial bucket.
Yeah.
What, Sully?
I can't claim to actually have a good answer to that question, but one of the things we have tried to do in our case is to establish, for example, a joint research lab, which we did with the École Polytechnique of Yaoundé, where we had a common theme, and we would have master students both from here and there, and from this we had some amazing innovations that actually would emanate from that side in the areas of you know, digital and incinerators, etc. So, but I'm not saying that is the entire response to that question. But
let me ask a slightly unusual question, perhaps. If you could do something over again in each of your projects, and a lesson you've learned with it, what would that do-over be, and why? If you could do something over again, the painful lesson where you get your fingers cut and your knuckles burned, what would it be for others who are thinking about this kind of transfer, this movement between the North and the South? Liz, you're shaking your head. Sully's thinking deeply, and Nali's not quite so sure yet.
No, like for me, I don't think I would necessarily change anything because of the context we are living in. Like I believe that we took the decision, the best decision possible according to the opportunity that were present, or the But like, however, I would say, with respect to, there is clearly a lot of room to improve, to grow in general, and any new entrepreneur who want to take the knowledge, the technical knowledge, the science knowledge, and transfer it there, I think there are now training, education process, and business model concept workshop and that he need to be involved in, because it's not purely we have a technology here and then it will work there, but need some nuance and need some adaptability and flexibility. So but the error, we will make it anyway. As long as we haven't done our own error, I'm not sure that we will learn from it.
I respect that tremendously. And we're always learning, and part of our mission is also share the learnings as we go along. I mean, that's the key part. So you were.
Yeah. I mean, one of the things we always lamented in some of the collaborations we've had, especially in the area of technology, is that you do the research and there'll be nice demonstrators that are produced. But then, in terms of actually taking that into a product and which can then be deployed, there is usually a lack of mechanisms to actually industrialize or produce that locally, which then brings it back to the north and where it becomes again monopolized. And so one of the things which would be great would be also to start to really strengthen local manufacturing capacity of certain things there. And this is one of the subjects that we wish we could at least do something, but this is something that is a bit beyond what we can do as a university, so that some of those innovations can, after being finished, can also be industrialized rather than having been be brought here and then brought back at a higher price with IP, et cetera, et cetera.
Yeah, great point. So let me ask, is there a question I should have asked you I didn't ask you?
Oh, I'm not. Sorry.
Yeah.
Going once. I've asked you everything I should have asked you. Nothing else you want to share? Otherwise, I've got to.
No, but to touch on the last point, and that's kind of this infrastructure gap that we are trying to solve, right? And what we are doing is not to, like, currently we produce in Switzerland our product, and then for project we ship. But what we are discussing with the Swiss Development Corporation and other entities to help us fund a infrastructure project where we can produce our binder locally and not have the transport back and forth. Otherwise, you cannot be sustainable and more and affordable, right? Yeah. And this doing that for the manufacturing aspect mean that you need also to strengthen your researcher from local researcher, because they are the one who is going to operate your local plant, your local manufacturing. So it's kind of a completely different value chain, and which then go back to how do you bring these technologies moving in?
That was exactly one of the questions, which was posed, how do you scale up locally? And I think that's a really wonderful point. We have mechanisms here in Switzerland to be able to do that. There are quite a few questions here about the pricing structure and the content of Oxford, but you can come and ask him afterwards and talk to him about that, because that's sort of very specific. So there are about actually 6 questions specifically around that. So your material is quite popular to say that. This has been quite fun. I've enjoyed this with the 3 of you. Quite different. And I loved cooperation, collaboration, co-development, and really understanding that in the cultural context of the place. Rethinking science for innovation markets is a constant topic for us all, and it's not merely an academic exercise, but a strategic necessary for both emerging and, I keep saying, existing markets as well. This is an absolute necessity for both sides of this coin. For emerging markets, it presents an opportunity to leapfrog, as we've heard already here, traditional development models by leveraging scientific innovation as a primary driver of economic growth and social progress. And for existing markets, it ensures a continued competitiveness and resilience in the face of rapid technological change. We've just seen in the news some wonderful examples of some incumbents who were just out chest moved here. By fostering a more efficient and responsive science innovation ecosystem, we intend to unlock new avenues for regenerative development, create more high-value jobs, and address pressing global challenges, ultimately shaping, which we all want, a more prosperous and equitable future for all. I want to thank all of you for choosing to be here, of all 3 of these panels, for you online, for choosing to be with us, and for your questions. I'm just pointing at the cameras up there. They're not really there, but they're there, okay? I mean, let you know. And also a real thank you to our three panelists for sharing your wisdom, your insights, and your passion for making the world a better place. So thank you so much.
Thank you.